enjoy it after especially having physics 20, right? So, okay, so a balloon was inflated at 27 degrees Celsius. It has a volume of 4 liters. If it was heated to 57 degrees, what's its new volume? So this was just, well, it's the opposite of. But remember how, Matt, you said if you take a balloon and you put it into liquid nitrogen, what are you doing to the temperature of the gas in there? Decreasing it a lot because the liquid nitrogen is super cold, right? So that's why it would shrivel up. So then the volume gets really low, but then you take it out at room temperature and it will expand again, right? So this one, we're heating up a balloon. So say I have this balloon, okay, and I heat it up. I make the air inside it feel really hot. It's going to do what? Expand, just like a hot air balloon, right? So if you take, because that's how a hot air balloon works, is that they have that that gas or the fire going inside, and they heat it up, and they're heating up the air, right? And then that hot air rises, and it makes the balloon big, right? Yeah, okay. Anyways, the actual question. So it gave us temperature in degrees Celsius. Now you cannot leave it in degrees Celsius. It's very important. Okay? The other ones you could leave like ATM as ATM, but degrees Celsius is the one unit you must convert. Okay? So T1 then converts to 300.15 Kelvin. V1 is 4 liters. T2 is 330.15 Kelvin. So you rearrange to solve for V2. So V1 over T1 equals V2 over T2. All right, so V1 times T2. Okay, and you solve for V2. So 4.39 liters, so to sig digs is 4.4. So then you think about it logically. Okay, I started with 4 liters, I heated it up, and it ended up with 4.4. Okay, that makes sense, right? When you go through your questions, think about them logically too. So say we have a sample of gas and it has 6.8 liters at 101 degrees Celsius. What will be the final temperature in degrees Celsius? So that means you do your calculation in Kelvin, but you convert back to degrees Celsius when the volume is decreased. So if I'm decreasing volume, this must mean that I'm putting the gas under colder temperatures, just like that liquid nitrogen thing. We put the balloon into the liquid nitrogen. So T1 converted into Kelvin. So 110 degrees Celsius is 383.15 Kelvin. We don't have to change anything about our V1 or V2, but it is important to write them out so that you know which one to go on which side of the fraction. And write down specifically V1 or V2. Don't just write V and V, because I wouldn't know which one to use. Set up your fraction. And solve for T2. T2 is going to be 315 Kelvin. You need to convert it back to degrees Celsius. So you have to minus 273.15 Kelvin. So you get 42 degrees Celsius. Is there one more example? Is that it?